anything that is, hard to do. I'm all for motivating. I think I was saying the other day that anything is a competition. You just have to try hard enough. Um, it's kind of serendipitous that you're talking about rapid prototyping, because that's basically my job now. I'm a staff engineer at 7 Shifts. I've been here about 4.5 years, doing this in the role for a year and a bit. I get to deal with ambiguous requirements and strange problems, provide technical leadership for the teams and department. And I get to think about long-term problems and issues that we might be facing and try and figure out fun and interesting solutions to those. So it's lots of fun. I kind of like to say I have a dream job, and it's still pretty surreal. Every day I wake up and I get to come and do this. So yeah. So today I'm gonna kind of blast beat all the way through these. I kind of judge the quality of my talks by the memes per minute, and I did not get enough into my slides today, so we're just going to try and plow through them. Legacy code is a natural artifact, of course, of maturing systems. It is code that currently exists in projects for any number of reasons that could be set to be replaced. 7 Shifts, we have one significant piece of code that is legacy and has been around since inception. It's deeply coupled to a lot of our systems and is in dire need of being replaced. This chunk of our system has served us very well for the growth we've had, and provided us with many wonderful shortcuts to quick prototyping, quick delivery of product, and making our customers happy. So inevitably, we came to this point where this piece of legacy framework wasn't able to be updated anymore. It was providing blockers to moving quickly and getting things out fast. So trying to figure out along this path to how we address this problem, I explored the use of the Strangler pattern to isolate and try and eventually remove cake PHP. So our code base is quite large and dispersed, and has many areas of concerns. We use a monolithic application as a mechanism to deliver application to our clients. We have roughly 130 people, I think, in engineering and R&D across 14 teams. We're continually shipping and delivering new product and value every day. So you'd think a monolith usually implies something large, unchanging, and with the size of our department and the growth we've had, you'd think we'd be slowing down more and more. But we've been able to maintain our velocity through the diligent use of patterns, and those software patterns that help us continue to maintain our speed and continue the growth we've had. So I'll start by touching on a few design patterns that we use here at 7 Shifts across our application. A lot of these patterns were essential to kind of figuring out the implementation details for this prototype that I came up with. I wasn't sure the audience and like the skill level and experience, so I'm gonna blast through these software design patterns and have the resources at the end. You can look them up or reach out to me or whatever. Just kind of touch on, give you an idea of what they are, how they work, and please dig into them if you're interested, find out more about them because it's super interesting. So we're surrounded by systems. Sorry, I forgot about this slide. We're surrounded by systems that reduce separate concerns into varying subsystems. Cars have power plants, drivetrains, electronic clusters, and xenomorphs have organs, nervous systems, cardiovascular systems, and acid reservoirs. It makes sense that we should also slice our software systems down into more manageable modules. My first tech job was at a hosting company in Regina. We maintained servers and built websites for a handful of small local organizations. Part of my first job was updating and maintaining this giant Perl script that served up all the customers' websites. It was already complicated, and Perl, regular expressions, was a nightmare. So smashing everything into this one big script made updating and maintaining it an absolute pain in the ass. Everything was mixed together and held together by sheer will, I'm sure of it. So I learned pretty quickly that breaking down those scripts into their dispersed concerns and modules made it a lot easier to maintain, a lot easier to update. It did not, however, make me hate Perl any less. So separation of concerns is a principle used in programming to separate an application into units with minimal overlapping between functions of the individual units. Separation of concerns is achieved using modularization, encapsulation, and well-defined interfaces. So most agree that this term separation of concerns was coined by Edgar Dijkstra, in his article on the role of scientific thought from 1974. And a lot of patterns were essentially drawn out further after this article was written, based kind of on this idea. So that's a very broad and obvious definition of separation concerns. But in practice, we at 7 Shifts, we use layers of isolation. So this is like MVC layer, sort of. It's kind of like what cake PHP looked like way back in the day. The layers of isolation concept means changes made in one layer of the architecture generally don't impact or affect the components in the other layers. The change has isolated the components within that layer and possibly other layers like persistence or SQL. Yeah. More specifically, we use domain-driven design, bounded context, hexagonal architecture, or onion architecture to help us reduce complexity and keep our teams separate. In his book of the same name, Martin Fowler states that domain-driven design is an approach to software development that centers on the development of programming a domain model that has a rich understanding of the processes and rules of domain. Bounded contexts are a central part of that domain-driven design. Is the focus of the DDD strategic section, which is all about dealing with large models and teams. Really, these patterns ensure that teams can focus on their core of their responsibilities and not be burdened with the cognitive complexities of everyone else's stuff. Dependency injection, another pattern we use quite frequently. It's just a fancy way to say for giving an object its instance variables. You provide the objects it needs instead of letting it get those objects themselves. You can inject those dependencies into an object through a constructor or through setters. It's useful for a few things, some of which are decoupling the creation of the object from its usage. It's easy to swap out other implementations of the dependencies with other ones without changing the dependent classes. And it makes testing so much easier. Another pattern we use is containerization. So containerization, well, this is a funny joke. So if you want to read it, if anyone here is like a DevOps person, you know, it's funny. Containerization is a mechanism for packaging a code base and its associated libraries, modules, dependencies, and components, then serving that application in its own isolated container. Most modern web applications do this as it provides a ton of benefit over the traditional mechanisms serving applications. Some of those benefits, most related to this talk, are things like it's easy to manage at scale and resource allocation. The containers are portable and easily reproducible across different environments. And it's the closest thing you can get to complete isolation other than like bundling it up on a machine in a bunker disconnected from the internet. So now we're at the meat of this talk. The pattern, strangulation pattern, is a pattern in which old systems are put behind an intermediary facade. Then over time, external replacements for the old system are added behind that same facade. The industry refers to this pattern as strangulation or Strangler pattern. During my experiments and subsequent proposal, I was calling it the cake jail. This term has always seemed a bit harsh, as I kind of feel that cake has been really good to me over the years. I've used it in lots of my jobs, and it's got 7 Shifts a long way. And I would love like proposing that we change this pattern name to something more like retirement pattern or aging gracefully, or maybe like out to pasture pattern. So I feel like our friend has worked so hard in his career, and we just need to give it the space it needs to kind of move on. Got that twice, 3 times. That's how much it meant to me. So this pattern, this is a diagram of the pattern. It's fairly straightforward. The pattern it's typically used to transform monoliths into microservices, but I think maybe it works also quite well to deal with legacy code and within monoliths as well. At least that was my thought, and I don't know, I think it worked out. So a routing facade intercepts the incoming requests headed to the existing system. Calls to the legacy system are then passed through the facade over time. We strangle out that old service by routing calls to the new service. Client interfaces continue to operate unaware that any changes have been made, and things just carry on until eventually it's gone. So the pros of this pattern helps reduce risk when migrating to new systems. You have the kind of divide and conquer. It allows old services to coexist with new ones, and they can be developed and tested in parallel. And it gives you, you can have an example to look at, make sure things are working. It's easy to implement and understand. The code complexity is very low, and lets you quickly deliver value and see results much faster than complete refactors. So there's a few downsides potentially. Risk of legacy code being not addressed once it's moved behind these facades and no clear path of removal. So you might stick it in this jail and, that's fine. We'll just leave it now, not worry about it. Requires a lot of attention to the boundaries between the old and new parts, the connection points, data exchanges, that sort of thing. And it can inadvertently lead to more tightly coupled code just through the nature of facades. So as mentioned in the introduction, our web app is still very tightly coupled with Cake PHP framework, and it's no longer being maintained. So these were kind of the catalyst of why we needed to look into getting rid of it. It's become a top priority, and this tight coupling, here's some of the reasons, sorry. Security concerns, so unmaintained framework. There's lack of boundary isolation. It's easy to mix concerns up. Array-based ORM, magic find methods, joins across domains, complicated to debug, still traces of the MVC patterns that are kind of anti-patterns in our frameworks now. And I want to get on PHP 8 and it's preventing us from doing that. So fortunately, along the years, we've kind of implemented a lot of these patterns that we mentioned above and solved a lot of the problems actually that we needed to do to implement this and pull it out of our system. So as you can see here, there's a table that shows what the analog is for the Cake PHP thing. So models, we have repositories, domain objects, AJAX, app controllers. We can move them to full-on SPA. API controllers, we have HTTP controllers and Slim controllers, and components through middleware and any use of the above things. So we've kind of got that in place, which is great. So my proposed solution, I started with the Cake PHP models. I figured that was the most plentiful. It was sprinkled most out throughout the app in most places. It seemed the riskiest, and it seemed like the most impactful thing to solve first. So there's a description of models on the Cake PHP 2.0 page, and I'll read it to you now. Usually, models classes represent data and are used in Cake PHP applications for data access. They generally represent a database table, but can also be used for access to anything that manipulates data, such as files, external web services, iCal events, ... To add to that wonderful description, it also has magic find types, magic functions that can be used as shortcuts to search your tables for a certain field. Just add the name of it to the field, in camel case, to the end of the functions and supply the criteria for that field as the first parameter. Unfortunately for us, Cake models are basically just balls of magic. They can do everything you could possibly want without any regard for performance, bounded context, scaling, or just ensuring that readability is a thing several years in the future. Fortunately for us, though, Cake PHP models are a big blob of magic, and I'm a magician. So it made creating a facade much simpler, as we could leverage that magic to do a lot of our dirty work. The trick to this whole proof of concept was ensuring as little disruption to the entire code base as possible. There are calls to these methods literally everywhere, and I wasn't about to search them all out and swap them out into a facade. By harnessing the container and the dependency injection, and creating a register for these model classes, we can create a wide-reaching changes with no impact to the developers or other parts of the code base. They're essentially circuiting every place that calls to our registered models to use the decorated Cake jail class. So you can't really read this code, but it does some cool stuff. It registers the models to be strangled. We iterate through those registered models, create an entry in the DI for a decorated Cake jail for each model, and then alias the old model class to the new injected class. So essentially the code just thinks it's the same stuff. Part 2, the facade. So, hey look, we're using PHP magic methods, this time for our own evil agenda. PHP call and call static methods give us the name and the method being called and an enumerated array containing the parameters passed to the named method. We can take the method name and serialize those parameters and make an HTTP request to an internal route served up by our legacy Cake PHP container. Deserialize the response and return the calling class. It works perfectly in the same way as far as the calling class is concerned. We have the benefit that Cake PHP models always arrays. So it made it really easy to kind of serialize and deserialize this. You can easily swap this out, HTTP request for gRPC or something else. Final piece of the Strangler pattern implementation is how we serve up the legacy code. So we gather up the requests in the JSON body, destructure it into various parameters, instantiate the requested model, pass the arguments through, and capture the returned array. Serialize and pass back a response back as an HTTP response. Wrap the whole cake PHP up in a Kubernetes container, add it to the cluster, set the load balancer, and then done. Easy peasy. So this is kind of a diagram I quickly slapped together of the flow. You can see each of the patterns I talked about before is kind of represented here. You can see that illustrates the Strangler pattern, but also each of the other ones, like separation of concerns. You can see each of the modules are split out on their own. Dependency injection to alias the cake PHP model and the appropriate adapters, facades, adapters, and containerization. Yeah, it's all kind of there. So can anyone see the key difference between this approach and the traditional approach I talked about? It's a rhetorical question. I'm not going to make you answer. We're not swapping out the new services with the old in this facade. It requires changing out the model at each place in the code base and eventually deregistering that model from the facade registry and then deleting the legacy code. So while we did not use the exact implementation pattern in our primary solution for removal of cake PHP, it doesn't mean that it wasn't valuable to dig in and understand how this pattern might have worked in our system. We now have an extra tool at our disposal should we decide we need it for another migration or some other thing, or another project that might require a similar approach. It's important to not only know about software patterns, but to try them out, experiment within your own code base. Find some crazy stuff and do it. It's a great way to learn. So legacy systems should be treated with reverence and respect. Every piece of the code is legacy code as soon as it's committed. Take the time to know and understand these systems and let them retire peacefully. Strangler pattern, aka out to pasture pattern, lets us tackle larger problems while mitigating risk by providing mechanisms that favor small changes over time as opposed to large, more risky, immediate ones. Thanks.